This video is going to be about the 30, 60, 90 special right triangle and how to solve some examples. Some of them will be really, really basic, and then we'll get into more complicated ones very fast, fast-ish. Same thing as the other 45, 45, 90. We're going to go ahead and sort of do it two different ways, right? We're going to either do it the pattern way, which, sometimes it's a super shortcut. You go ahead and you can go ahead and, just solve, or we're going to do it using the table way. The pattern way, I'll go ahead and explain how that looks, once you see it. In the table way, just like the 45, 45, 90, we're going to think of it as like what is the most basic triangle that we can use that follows the 30, 60, 90. And so if you recall, the 30, 60, 90 comes from an equilateral triangle, right? All the angles are equal to 60. And then what we end up doing to get the 30, 60, 90 triangle is we draw this line down the middle here. I think it's called the altitude median. I don't really remember, let's be honest. So you see where the 90 comes in. That's because it's perpendicular, since I think it's an altitude, and then this over here is an angle bisector. Okay, so that's how you get the 30, 60, 90. And so for those of you guys that remember the video, you know that there's a pattern, right? That this over here, this side is basically bisected by this side, by that new line that I drew. And so then I could put two little tick marks there, representing the fact that they're congruent to each other as well, the two red marks. And so since it's an equilateral triangle, I can go ahead and I can give it sides, right? Now, we're talking about the most basic triangle. So I can go ahead and I can choose one for all of the sides. But then what ends up happening is that right here in this little like section for the triangle, it becomes 1/2, and we don't really want to use that just because of the fact that it's a fraction. It's going to make stuff a little bit harder. So instead of choosing one, really think about how it's going to be, or what numbers can it be that'll be easier. I'm going to choose 2, because then when I get this bottom sides, they're both equal to 1. And so now you avoid using fractions, and you have like the smallest integers possible, right? 1 and 2. And for those of you guys that remember the pattern, to get the missing side, which is going to be this one right here in the middle, right? It's going to be the exact same length as the short side, which is a 1 square root 3, right? It's just a pattern, right? If you don't understand where this is coming from, then I suggest you go watch the pattern video for the 30, 60, 90. And so this sort of brings us to our table and our pattern, right? Very quickly though, one thing I do need you to understand is this right here, which we covered in the other video, but it's just going to be a reminder. All right. Let's see. The most important one is the hypotenuse, right? The hypotenuse is always across the 90 degrees. And if you notice here, right, the pattern basically tells you it's 2x, where x, if you look at the other sides, is going to be considered to be the short side. Okay, so that is something that is really, really important. Okay, short, what is it? Yeah, I call it short side. So the short side is always, the short side will always be across the 30 degrees. So technically in a triangle, right, the side lengths go in order based off of the angles that it is across. So since 30 degrees is the smallest angle, that means this side right here is the shortest side. Now, what I want you to notice is on this one here, I called it the long side. I didn't call it the longest side, right? Not this one. Careful in using this word. It is not considered to be the longest side, right? The 61, because the longest side is technically the hypotenuse, right? But anyways, just comparing the two sides, 60 is the next number, and so then that means this side over here would be considered the long side. The pattern basically states, if you have what the short side is equal to, all you have to do is put that there with the square root 3 behind it, right? That's what the pattern is. And so then that's what we get here. Okay, so most important thing, if I were you, I would go ahead and I would just label short side, long side, and hypotenuse every single time before you start a problem. So here goes. Finally, here goes the pattern and the rules, if you want to think about it in the pattern way right here, and then in the table way. I already explained this x and x square root 3 and 2x. If you really think about it, right, let me do this here. The short side is connected with the hypotenuse because it's double, right? So if, for instance, if I give you 4 here, then automatically that means it's 8 over there. And then the short side is related to the long side, just because you're going to go ahead and just, tack on a a square root 3 behind it. So if I gave you 4, that means this side is going to be equal to 4 square root 3. Now I know that doesn't really look like a number, but it is, right? Square root 3 is equal to like 1 point something something something, and then we would just multiply that by 4, and that'll be the new number there. But we're just going to leave it as square roots. And so now let me go ahead and try and explain the table. Now the table has it in very specific order, okay? 30, 60, 90. So you're going to go in order of smallest side to longest side. Now, I told you guys that when I did the equilateral triangle right now in the first slide, that the basic numbers that I chose were going to be 2 for the equilateral triangle, right? 2 for the equilateral, because of the fact that when I break this up into my 30, 60, 90, that means this here is equal to 1. Okay? And so what you can already tell here is, look, if my 90 degrees is there, let me actually draw it. My 90 degrees is there, opposite it is the side with the 2, and that's why you get the 2 right there. And it's across the 90, that's why it's below where the 90 is. And now if we go ahead and remember, this is an equilateral triangle. Right here is an equilateral, so that means this one is equal to, sorry, that is totally wrong. This one is equal to 60 degrees, you know, because all of the angles in an equilateral are always equal to 60. So what ends up happening here is, let me just, you know, do my arrows. So the 60 is across this side right here, which is going to be considered to be the long side. And we know that that pattern is the square root 3, because we're just going to put the 1 in front of it. And so that's why you see that right there. And then finally, the last one is going to be the 30. And so let me go ahead and let me make some room here for it. Okay. So then the 30, when I go ahead and I draw this line to create the 30, 60, 90, this side is 60. And then this over here is, what is it? Like an angle bisector as well. So then that means the 30 is opposite the 1, and that's why you see that there. Okay, so it's always really nice to organize yourself like that. So let's go ahead and let me just show you how the table works and how the pattern works. The first couple examples will be really easy. I will tell you that, okay? In this first example, the first thing that I always suggest you do is just label your sides, you know. For this one, it's hypotenuse, we have the short side, and then we have the long side. That's the first thing I suggest you do. And we know this comes from, you know, the 90, the short side comes from the 30 degrees, and then the long side comes from the 60. So that means this one here would be considered to be the hypotenuse, 30 degrees. This one would be considered to be the short side, and then the last one obviously is just going to be the long side. And so now you have to think about what information is given to you. Well, the hypotenuse is given to us. So then that means we have, we could potentially, you know, work backwards and see, can I figure out what the short side is equal to? Because, you know, the short side is across the 30 degrees. And so that's how they relate, right? If you can figure out how to break it down. So now it's 2 times something, and that's just something we're trying to figure out, which this one, it's a little bit easy because it's 14. So you can easily just say 2 times 7, and so that there means this here is the x in the equation there. Now just be careful because it might not be the same letters here. You know, in this example it was, but just be very careful, okay? So 2 times 7, this one, I'm going to consider this to be the short side. All right, so then I can go ahead and, since 7 is the short side, that's what it is here. So it'll be x is equal to 7. And then after that, right, we can just go ahead and move on to the long side, because the long side, all you have to do now is just compare these two. And it's just using the short side and tacking on a square root 3 behind it. And so then we can go ahead and we can do that by just, you know, doing exactly what it is. Bring the short side and then tack on a square root 3 behind it. And that'll be what the long side is equal to. So then there we have our 2 answers. Now, I know that maybe my explanation could be a little bit confusing, and some of you guys will probably understand it a different way. And that's fine, okay, as long as you're doing it using the pattern or the table. So let me right now go ahead and do the table way. Now the table, it's always going to be the same. It'll be 1 square root 3, 2. And then the really nice thing about it is it's always 30, 60, 90. It goes up in order, okay? And so then what you're going to do is you're just going to look at the initial triangle they gave us. So that triangle right there. And we already labeled them. So that's really nice. Now we're just going to put the correct letters or variables in the correct spots. So for instance, the first one is the 30 degrees. So I look at the short side, the one that's across the 30. So that would be x. So that means x would go right there. And then the next one is going to be the 60 degrees. And so then we look at where's the 60 at and what's opposite of that. It'll be the y. And you know what? I think I'm just going to go ahead and just clean this up a bit just so you can see what I'm talking about. So this is the short side, this is the long side, and this is the hypotenuse. Okay, so let's go ahead right now because I'm just trying to show you how to do the table method. So yeah, 60 is, sorry, that's way bad. 60 is across the y, so then that's why y goes right there. And then the 90 degrees is the 14, so that's why it'll go right there. And then the same thing as before with the 45, 45, 90, you're basically choosing a letter that you want to solve for first, and then you go ahead and you solve it that way. So already we know that we have two variables. Oh, sorry. We have two variables here, x and y. You need to be smart about, you want to solve for one variable, so you're only going to use one variable at a time. So let's say, for instance, I want to solve for x. So it'll be 1 over x. Remember from the previous video, you cannot choose this one here, because if you do, what ends up happening is you have one equation with two unknowns, and so that means this equation is basically impossible to solve. So you need to be using basically just information. So for instance, that means I cannot use that one. I have to use 2 over 14. And now we have one equation. We only have one variable, which is the x, and so that means I can solve this. So I can go ahead and cross multiply. It'll become 2x is equal to 14. And then all I have to do now is solve for the variable, right? Isolate the variable. And then we get x equals 7, which is exactly what we had gotten already with the pattern way. So let me go ahead and make room so I can do the next one. I'll draw a line there to not confuse us, the work. So now let's do, we solved for x, now let's solve for y. Now I obviously need the y. And so, oops, sorry, I erased that one. That's not 1, that's 2. And so what ends up happening is, right, of course, you need the square root 3 over y because that's what you're trying to solve for. And then you need to use 2 over 14. If you want to, you can already like substitute the 7 in there, and then you could even use the 1 over 7. It's completely up to you. But if you're not 100% sure this is right, then I would just suggest you use the 2 over 14. It's just a little bit easier, I think. So then let me go ahead and let me cross multiply, and let's see what we end up getting. So cross multiply, we get 2y equals 14 square root 3. Remember, the 3 is inside of a square root, the 14 is outside, so we cannot multiply them, like the actual numbers together, like 3 times 14 and stuff. So next, we're just going to go ahead and isolate the variable by doing inverse operations. 2 divided by 2 is 1, so I end up with y is equal to. Now, you can decide to either leave it like this, but if it's a multiple choice problem, you're not going to see this here. The reason for it is because you can actually divide 14 with 2, since they are, let's say, numbers outside of the square root. So we can actually go ahead and divide them, and so we get 7 square root 3. And then there you go. That's our two final answers. A little bit more work, a little bit more algebra, but I mean, you're going to end up at the same exact answer. So if you want to do it the pattern way, go ahead. If you want to do it the table way, go ahead. Let's go ahead with the next one and see if you guys are able to get it. Of course, the first thing always to do is to label, and that's just by looking at the angles. So 30 degrees, that means the opposite of that one is going to be the 6, so this is the short side. 60 degrees, the opposite of that angle is going to be our long side. And then probably the easiest one for some of you guys, it's going to be the one opposite the 90 degrees, which is the hypotenuse. So we have that there, okay? That's just by, making the lines, making the opposites. And so the next thing we can go ahead and do is going to see, well, what information do we get? So 6 is our short side. So we actually got this here, which means that it's a really, really nice, easy problem, because if you notice, all the other answers depend on knowing that number, which we do know. So we can automatically just, plug stuff in, really. So let's see, the relationship between short side and hypotenuse, you're just going to double it, right? You get x, and then you end up with 2x, so you're going to double it. So it'll be 2 times 6, which is equal to 12. So that means x is equal to 12. Now, to see the other one, let's go ahead and let's see the relationship there. So from short side to long side, the relationship is you're just going to put that number there with the square root 3 right behind it, multiplying. So since we do have that number, all I have to do is just say, hey, here goes the 6, and then here goes the square root 3. And that's our answer for y. And then there you go. You see, like, it's so easy when you have Basically, the short side, it's the easiest problem because you're just working with that number. So let's go ahead really quickly. I'm going to set up the table. I won't solve it though. I'll leave that for you if you're gonna actually, try to solve it using the table way. So 1 square root 3, 2. This isn't gonna change, right? Because remember, this is like my base triangle that I decided to use. That is a 30, 60, 90. And so just in case you forgot, right, it always goes in order: 30, 60, 90. So we already did the work for that anyway, so that's good, right? The side opposite the 30 was the 6. The side opposite the 60 was the y. And then the side opposite the 90 is the x. And so then there you go, right? You would either solve for y first, solve for x first. But remember, in your equation, when you set your two fractions equal to each other and then you cross multiply, you only can have one variable. Okay, that's really bad, but you know what I'm trying to say. One variable. Okay? You'd only have one variable. And that's what you need to be careful with. But I mean, other than that, it's not that bad. All right, so let's go ahead with the next example. Pause the video and see if you can figure it out. So for this one, same thing as we always start with. Let's do the labeling, which let's see, 30 across the 30, that's my short side. Across the 60 is my long side, and then finally across the 90 is my hypotenuse. So I'm going to go ahead and clear it up. Now let's see what information did we get. We got the long side. So that means we got this one here. Now the really nice thing about it is, check it out, there's the square root 3. So what that really means is you can separate this 10 square root 3 into like 10 times square root 3. Where I'm just pretty much just adding like a little dot there just to signify that multiplication, and you're separating it. It'll be 10 here and then square root 3, x there, square root 3. So that means we actually know what this x is here in the pattern, which gives us the side length for the short side, like just right off the bat. And so what that means is that the 10 basically becomes the short side. Now that's what I was trying to say, like don't think this x is the same as this x. If you want to, you can change variables, right? But just be very careful about that. So that means the short side is equal to 10. And then just by using the patterns, right, how do you go from short side to hypotenuse? We just double it. So then that means the hypotenuse is equal to 20, right? If you really want to, you could do 2 times 10. So it could look like, 2 times the short side, which is 10. So there you go, right? Pretty easy. X is equal to 20 and then y is equal to 10. Now, the table method for this one will look a little bit harder, but when you cross multiply for some of them. But let's go ahead and I'll set it up for you, and then we'll see if we actually need to do it. So let me go ahead and do this here. So it'll be 1 square root 3, 2. That's not going to change for the 30, 60, 90. And then I need to see the opposite sides. So this one is 30. So what's the opposite of 30? We have y. This one is 60. What's the opposite of square root? Of 60, it's 10 square root 3. And then what's the opposite of the 90? It'll be x. And so then what I want to do is, let me just solve for one of the variables, just so you can see that even though it does look intimidating, it's not that bad. So I'll solve for y just because it's the first letter there in the table. Whatever, right? So it'll be, let me give myself some space. So it'll be 1 over y is equal to square root 3 over 10 square root 3. If you notice, these two are square root 3, so we can technically cancel that out and leave like a 1 on top. And so then that'll become 1 over y equals 1 over 10. And then boom, that becomes a super easy cross multiplying. But I really want to say some of you aren't going to be really comfortable with that. So let me just go ahead and cross multiply just with that and see what's going on. And then also, you can't do that trick if, for instance, it would have looked, well, actually, no, the 3 should always be on the top, right? Because remember, this is never going to change. That's always going to be a 3. So let's imagine it's like that. You can't, cancel this out and then, make it become 1 over 10. So that's why I want to sort of show you a way of how to actually solve it when it looks like this. So it'll be y square root 3 equals 1 times 10 square root 3. So it'll look like that. Trying to isolate the variable. So we're trying to get rid of this square root 3 here. The way to do it is really think about this square root 3 is just a number. It's a number. It's like 1 point something, and it's being multiplied by y. So if we think back to, let's say, for instance, an example like this right here. and we're trying to isolate the variable, we would just divide by 2 on both sides, because then 2 divided by 2 is equal to 1, and then boom, y is by itself. We're going to do the exact same thing for this one, but now instead of dividing by, let's see, a nice little integer, we're going to divide by square root 3. Now, I know it looks weird, but it works, because look at this fraction here. It's square root 3 divided by square root 3, which we know, even though they're decimals, even though they're square roots, it's the exact same square root, so therefore it becomes 1. And so we get y here. And then the really nice part that happens in this problem is that it also cancels out, because these also match up. If they didn't match up, then you will not be able to do it. You would have to rationalize. And I'm pretty sure we're going to have an example like that in another example in the video. So let's just wait for that right now. But there you go. Y is equal to 10. So there you go, right? We can go ahead and we can try and do the same work for x now, but it'll pretty much follow the exact same patterns, right? You're just going to have to circle this one now and this one, and that'll be our equation. Okay, so let's go ahead with the next example. Just be very careful with how the 30 and the 60, how that can change, label, and then see if you can solve it. So by now you should know the first step always is to label. So I'm going to go ahead and start with the 30. That means this is the short side. Next thing I'm going to do is the 60. So that means this is the long side. And then finally the last one is going to be the hypotenuse, which is opposite the 90. You don't really have to follow the same pattern that I do, 30, 60, 90, but there you go. Okay, you could do hypotenuse first, right? It's up to you 100%. And so now let's think about, what did I get here? I got the 8, which is a hypotenuse. So I got this one right here. So I got the double, which is really nice, especially because 8 is, you can break it down into 2 times 4 fairly quickly. And so what that means is that this 4 is equal to this x value here, which we know it's the short side. So automatically I can just move this already over to here. So I know this short side is equal to 4. So that's the really nice thing about, they give you the hypotenuse and it's an integer that you could easily break up into 2 times something. And so then automatically, right, x is equal to 4, because that's the variable right there that's being used. And so now let's think about, well, how can I get the long side? Well, look at the relationship between short side and long side. All you do is put the short side there, and you're going to multiply that with square root of 3. So that's exactly what I'm going to do. I'm going to do, here goes my short side. I'm going to multiply that by square root of 3. And then there you go. That is y. Okay. So my 2 answers fairly quickly. If you want to do the table, go ahead. If you plan on using the table all the time, I suggest you practice it. You already know what the 2 answers are anyways. So let me just set it up for you. 1 square root 3, 2. We know this is 30, 60, 90. And so now there's the bottom 3 numbers here is the information we're going to get from the triangle we're actually trying to solve. So the side opposite the 30 is the x. The side opposite the 60 is the y. The side opposite the 90 is the 8. And so then you can go ahead and just do the work. For those of you guys that are looking at the pattern, I mean, it's in here as well. Look at that. The hypotenuse, because we know the hypotenuse is the one opposite the 90 is a 2, and we know that the 30 is the short side. And look at that. It goes from 2 to 1, depending if you're going in this direction. So that means it's obviously half, so you could go ahead and do 4 there really, really easily. But, whatever, it's up to you. I'm just going to let you guys cross multiply. Go ahead, right? Whatever works for you. And so finally, this is a hard problem. You're going to have to really, this is where the pattern sort of breaks down, and just pause the video and try to write down, why does the pattern break down here? For this one, let's start. Of course, labeling across the 30 degrees, that's going to be my short side. Across the 60, it's going to be my long side. And then across the 90 will be the hypotenuse. Alrighty, so that right there, let me go ahead and see what information they gave us. They gave us the 5, which is the long side. And if we remember, for the pattern, the long side will be really easy. I'll put 30 here. No, I'll put 60 here. The long side, the pattern would be easy if we would have had a square root 3 there, because then we can just take, the number in the front. But we don't. We have only 5. So that means this is a super hard, not super hard, but just a really a more difficult problem, just because it's going to have you do a lot more work. So the way to do this is the table, 1 square root 3, 2. And then let's go ahead and let's fill this out. So 30 degrees, it's going to be the letter D. Across the 60 degrees is going to be 5. And then across the 90 degrees is F. So if you notice, right, we're going to have to use this one for whichever one you're going to solve for first, because, I mean, that's the only one that has a bunch of information or just numbers, okay? So it's basically you decide, do you want to solve for D or F first? I'll solve for, let's say I'll solve for D, whatever, okay? So then there goes my two fractions. I'm going to set up the equation. It'll be 1 over D is equal to, sorry, that doesn't look like a D, is equal to square root 3 over 5. Now we can go ahead and cross multiply. Right, so I mean, if you really look at it, it's the only reason why it's considered to be hard work is just because you're gonna have to rationalize. Okay, so we have there, even though it doesn't look like it, but D square root 3 is equal to 5 after you cross multiply. And then we're gonna isolate the variable, which in this case it's the letter D. So I'm going to try to get rid of that square root 3. Since it's being multiplied, I can go ahead and divide by square root 3. This is equal to 1 because they are the same number. And then we get here 5 over square root 3. Now, I mean, you can technically stop here and like feel 100%, good with yourself. But the only bad part about it is I don't really foresee that answer as being like a multiple choice answer. I'm not entirely sure. I haven't, for college classes, I'm not entirely sure if they're going to let you stop there. I mean, let's just be honest. I don't really know. So what I'm going to go ahead and do is I'm going to rationalize. And if you haven't seen the steps for rationalizing, I'll link a video in the description box that'll show you an example for rationalizing. So let me go ahead and let's do it. Let's D is equal to 5 over square root 3. For those of you that want to maybe like look it up on YouTube by yourself, right? Let me see if I can spell it right. Rationalizing. So really all we do is this super random trick, and the reason why we do it is because there is a square root in the denominator. That's the only reason. Like, let's say for instance, after we did the work, this ended up happening for D instead, then that means this here final answer, you are done. But because the square root 3 is in the denominator, that means we have to do this this next step. Okay, so let me do this here. It's a super random step where you're trying to get rid of the fact that a square root is in the denominator. So you're gonna multiply by whatever this number is. So it's a 3 in this case, so I'm going to multiply by square root 3 over square root 3. The reason why we do the same number, both numerator and denominator, is because this technically is just equal to 1, if you really think about it, because you can simplify it. So we're really like multiplying the fraction, right, this fraction right here, by 1, which means we're not really changing what it is, we're really just changing how it looks. So I end up getting 5 square root, sorry, it doesn't really look like a 5 for me. So 5 square root 3 over square root 9, because, 3 times 3 is 9. And so then I end up getting 5 square root 3 over 3, because the square root of 9 is equal to 3. And so this here would be technically our final answer, because look at the denominator now. It's no longer a square root, and it's just a nice whole number. If you notice here, we have a 5 and a 3. They don't simplify, they don't divide perfectly. So what we can just do is just leave it like this. So technically, this would be our final answer for letter D here. Okay, so D is equal to 5 square root 3 over 3. Now, we can go ahead and we can put this information in our table. Okay, so that's exactly what I'm going to do. I'm going to put right here 5 square root 3 over 3. That's for D, and then we have that 5. And now, you can go ahead and do this 2 different ways to solve for F now. You can this here, cross multiply, and do all the work again, or you can try to now include the pattern. So if you recall in the pattern, to go from, because this is technically the short side and this is technically the hypotenuse, to go from short side to hypotenuse, you basically just multiply by 2, right? That technically is the pattern. If you don't see it, look, it's right there. To go from 1 to 2, you multiply by 2. That's the pattern. So what we can do is just the same thing here. We can do times 2. So it'll be 5 square root 3 over 3 times 2. We could change that into a fraction if you want to. And then since the 5 and since the 2 are both integers outside the square root, we can go ahead and multiply them. And then that'll be our answer for F. And so there you go. Look, you had to use the table to solve initially for one of the variables, and then you can do the shortcut to try to figure out what the F is, or the other one. For instance, let's imagine that instead you were able to calculate this first, Then to go from this one to letter D, right, look at the pattern. How do you go from 2 to 1? Well, we would divide by 2. So we can go ahead and say this divided by 2, which, I mean, hopefully you remember, that means you multiply by, what is that, keep, change, flip. You multiply that by 1 over 2. And then we can go ahead and do, 3 times 2 because they're both in the denominator now, blah, blah, blah. So it's completely up to you how you do it. And then you could even simplify 10 with a 6, divide by 2 on both of them. It'll give you 5 over 3. So, I mean, it's completely up to you how you want to do it. Just understand that there's always, you're most likely for these type of problems, you're going to have to use the table. And then to finish the table, you can probably use the pattern way. So let's go ahead with this one here. It's probably going to be one of the hardest ones you see for this video. I actually changed it. It was initially 18. Now I'm going to change it to 18 square root 2. So let's see what you can do with this. Pause the video and give it a try. Labeling the sides, of course, that should always be your first step. So 30 here, so that means this is short side. 60 here, so that means, let me change color. 60 here, so that means this is long side. And then, of course, hypotenuse is always across the 90 degrees. So then there you go. Okay, yeah, that says hypotenuse. If you want, I can make it better, but I mean, it says hypotenuse. Sure. All right, so let's go ahead now and let's see what's going on. We have the long side, which is equal to 18 square root 2. If that would have been 18 square root 3, let me write it. If that would have been 18 square root 3 instead, yeah, this problem is super easy because then we would have just taken the 18, blah, 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 and then there you go. But the fact that it's a square root 2, it's going to get hard now. So same thing as before. Let me set up my table. 1 square root 3, 2. Remember, it always goes in order. 30, 60, 90. Yeah, that's a 6. Okay. 30 across the 30, it's, again, letter D. Across the 60, it's 18 square root 2. And across the 90, it's F. Okay, it's pretty much the same table as the other one, but just, different numbers, whatever. Okay, so for that reason, I'm going to solve for F for this one instead of D. So that is going to be my 2 fractions. So it'll be square root 3 over 18 square root 2 is equal to 2 over F. And so now here I can go ahead and cross multiply and do all that work. So we can go ahead and we'll get F square root 3 is equal to, well, 2 times 18, what is that, like 36 square root 2? Let me just make sure. Yeah. Okay, so then now I can go ahead and isolate the variable. I only care about the fact that I'm trying to solve for F. So let me go ahead and divide by square root 3. That cancels. I get F is equal to 36 square root 2 over square root 3. Notice that these two are inside the square root. So we can go ahead and, like, if they did divide, then that would be awesome, right? We can go ahead and divide those, but 2 and 3, that really doesn't do anything. So what that means is now the next thing I have to look at is the fact that the square root 3 is in the denominator. So that means this right here is the reason why I'm going to have to rationalize, okay? The square root 2 is just there. It doesn't tell me anything right now, okay? It's just there like a number, like an extra number. So what that means is I have to rationalize it. Oops, sorry. I was supposed to move the screen. All right. So in order for me to rationalize, I'm going to have to go ahead and multiply by, square root, and the denominator always determines what's the number, okay? Like I said before in rationalizing, if you do it correctly, the denominator will always simplify into a perfect square root, okay? So we end up getting 36 square root 2 times square root 3 over square root 9. Of course, always. The really nice part is look at the denominator. That always has to become a nice whole number afterwards. And then we get on the top in the numerator 36 times. Since both of them are inside a square root, we can go ahead and actually multiply it. So it would be 36 square root of 6. And so then we can go ahead also, and this is outside of a square root. This is outside of a square root. I can go ahead and divide that, and that'll give me 12 square root 6 over 1. If you don't understand that, I can go ahead and do it real fast. It's like if I do 36 divided by 3, that's going to be equal to just 12. Notice how the 36 is in the numerator and it's a bigger number. So that means it'll be 12 over 1 technically, and then that's where this is coming from. If you want to do it a different way, you can go ahead and do it like this, where you can divide by 3 on both of them. It's just simplifying fractions, really. That'll equal to 12, and then 3 divided by 3 is equal to 1. So I mean, it's up to you how you do it. And then I can go ahead and just take it one more step, and that'll be 12 square root 6. I don't need to put the 1 in the denominator because it's just the same thing. Now, if, for instance, it would have been, let's say, for instance, it would have been instead 3 over 36. Now this actually matters where the, where the 1 is going to be. So it's going to be 1 over 12. And then the square root 6 would be in the numerator still. Sorry, that looks like a 16. And so that's what it would look like, okay? So it's really important where the greater, larger number is, okay? So just really keep in mind that. And so here we go. That's the answer, 12 square root 6, and I forgot what letter we were solving for. It was F. So we have F is equal to 12 square root 6. So I can go ahead to my table, clear it up a little bit, and I know that this is going to equal to 12 square root 6. Now, you can go ahead and, boom, boom, solve for letter D, and good luck to you. It's solvable like that. It's going to take you a little bit of steps, but I mean, it's fine. But if you want to look at the pattern, if you have the hypotenuse and you're going to the short side, what's the pattern? To go from 2 to 1, we're going to go ahead and divide by 2. So all you're really doing is just going to say, hey, what's 12 square root 6 divided by 2? Well, that's just going to be equal to 6 square root 6. And I just don't like the fact that there's a lot of 6's there, but whatever, okay? So then my final answer would be 6 square root 6 for that one. So you see, like, there's always ways of, like, looking for shortcuts, but you're going to have to, for a problem like this, you're going to have to do this work here, right? Just being honest. It kind of sucks, but, there you go. All right, now this last one, it's really, like, super overkill, but if you really want the challenge, and this is for, like, people maybe in, like, honors or whatever, I mean, the only reason why this is considered to be a hard problem is the fact that this is a fraction in itself already. Let's see what else. It's the hypotenuse. I mean, technically, you can make this into a really easy problem by doing the pattern way, but it's up to you, okay? So I'm not going to solve this one. I'm just going to go ahead and give you the answers, and then you can go ahead and see if you get it right or wrong, okay? But this is honestly the hard one. The really quick thing I want you to see is I didn't put what is it called? A degree in there. I mean, you can figure out what that degree is equal to. If you can't, then I don't think you should be trying this example. Let's just be honest. So let me go ahead and just write what the answers are. Okay, so let's see. The answer for X is going to be equal to 5 square root 2 over 6. And then the answer for Y is going to equal to... it's going to equal to 5 square root 6 over 6. I mean, you can really just, like, make up these problems all on your own and then, try to see if you can solve them. Throw in some square roots in there. Throw in some fractions. It's completely up to you, but there you go.